folks. And so without further ado, Michael, go ahead and take it away.
All right, thank you very much, and thank you for having me. Again, my name is Mike Swartwout. I'm an assistant professor of aerospace and mechanical engineering at St. Louis University. I apologize up front if I seem a little raspy. It is uncharacteristically winter here in St. Louis. We're in the 20s and have snow on the ground, and that's not supposed to happen here at this time. But we'll soldier on anyway. I'm also presenting on behalf of the chair of our department, Sridhar Kondor, who did a lot of the early work here, and so I wanted to make sure to credit him as well. All right, so in terms of getting quickly with the bios here, Dr. Kondor is the chair of the department, and he is the primary teacher in our sustainability and product design sequence. I am an assistant professor, and I'm responsible for our new undergraduate freshman engineering course, and so I'm involved in incorporating that at the freshman year. I also come from a very different direction. I have been working mostly in spacecraft design, and so it's nice for me to branch out. So just quickly, St. Louis University is the College of Engineering is called Parks College, named after our founder. In fact, we are the first licensed aviation school in the country. We have FAA license number 1. Since then, we have expanded to cover a wide range of engineering disciplines. We're a fairly small school, about 700 undergraduate students. About half of them are aerospace and mechanical engineering majors, which means, again, about half of our students are at least entering into the sequence that I'm going to talk to you about today. So mainly what we're doing is we've got 3 courses here that we're using the sustainable minds and the life cycle analysis. The freshman year, MENG, Mechanical Engineering 101, a sophomore level design course, MENG 200, and then a senior elective, and I will quickly talk about each one of those as I go through here. So in 101, this is again a required course for all of our majors, and again our aerospace take this as well. It's a class project that comes near the end of the semester, about 3 weeks in length, and fairly small teams that are working on this. And as I said there, for the pilot program, this is our first semester doing it. We're just using one of the sections, so just 24 students are working on this. And what we're doing is we're taking an existing activity, which is a toaster teardown, to teach them the design process, to encourage curiosity, have them take apart a toaster, see how it works, see how the mechanisms are there, the electrical, how that also merges with the ideas of design. But then, so on one day they take it apart, understand all the functions, how it works, why the decisions are made to make a toaster the way it is. Then we say, now that you've taken it all apart, let's go back and look at each of these pieces and do an environmental impact to sustainability analysis. And so they can assess the life cycle cost. So what we're doing is having them go look at the materials, research some of the manufacturing, and again come up with an idea of the costs involved here. At this point, being at the freshman level, what we're emphasizing is the process of using the application, asking the questions in terms of what is the true cost of building and producing something. And then also there is a particular question here in terms of what could they do in terms of what are the drivers, what are the things that are having the most impact, as Terry was talking about with that total score. That prepares them for their sophomore level course, which again all of the mechanical engineering majors take, Introduction to Design and Manufacturing. And this is a rather significant class project there. So in this one, that's more open-ended, and so we're asking them to approach a design problem, and they're going to be using the life cycle analysis as one element of the design process. So they have a small amount of money for materials, and what they're being asked to do, or what they've done in the past, and we do cycle through several different projects, is a solar oven. And the idea here is that from a design perspective, they want this to be useful and used, and so what each team has to do is identify a region in the world where they're going to for which they're producing their oven, but also a nonprofit, some organization which would know the area, would know the people, be able to participate there, and so they have to do some research in terms of what are the actual needs in that area, and who's working to meet those needs. We have them doing understanding the culture. I'll talk about that in a little bit here, but basically, to the extent that they can do from St. Louis, they go to a local restaurant to understand the culinary habits, what sorts of foods are cooked, how they're prepared, how they're eaten. So again, they can do a better job of truly assessing the needs and then come up with a design that meets them. They do design a prototype, test it out, and then again, using the life cycle analysis, can evaluate the environmental impact here. So again, as we said, solar oven, I just talked about this, but in terms of the pieces here, again, especially understanding what would it take for this oven to be adopted. So rather than just, again, coming with this great design and dropping it in and expecting it to be widely loved, really understanding the culture and in terms of how this would impact it and how it could be beneficial. Again, from both a society perspective and a cooking habit perspective. Now, from what we would think of as design, but as we know is just one aspect of design, is now to go into the prototyping, come up with different concepts, evaluate them through trade studies, and implement them into an actual prototype cooker. So there's an iterative process. They are doing modifications. They are trying to do everything related to what it would take to produce this. So from the evaluation, the assessment part that comes at the end, they're looking at the business model in terms of what it would cost to produce it, how they could sustain that from an economic standpoint, but then they're also looking at the environmental impact. For this class, we had them focusing on carbon footprint within the impact factors of life cycle analysis. They're using the Sustainable Minds software to study the entire environmental impact. And here again, they're looking for ways to improve their response. So this was one example in terms of the various pieces that they're doing. Again, these are solar cookers, and so it's just mainly reflective surface and some box material to hold it on. They have to look at how well does it heat up, and then what sorts of pieces are going in here. So again, there's a quick screenshot of the impact of different categories, how each of those pieces are affecting there. And again, some of the things that can be pointed out in terms of what they're doing to human health, in terms of human toxicity, but also in terms of the ecotoxicity, and understanding for them in terms of what toxicity is and how it impacts different parts of the problem. That's something that the students wouldn't normally consider. So we can have them broaden their horizons a bit. So in terms of one student's reflection on this, the team said their eyes have not only been open to the many issues in the world that engineers must solve, but also our team's thought process has changed to be more of a global, innovative, and sustainable mindset. It's a really popular program among our sophomores. So at the senior elective and also master's degree students take this. There's an innovation, creativity, and sustainability course. And again, this was a large project that takes up a significant fraction of the time and in a large part of the grade. So in this particular project, the idea is to build on what the students have been doing in the freshman and sophomore years, and in fact to come back to the toaster. We like the idea of connecting things that they've done to seeing it again. Now that they're seniors and they have the greater technical knowledge, we can ask more of them and they can do more in the project. So here, the idea is to go back to the toaster and reassess it. Can you do life cycle assessment to adjust the design of the toaster? So here, this is really using the software front and center to understand the environmental impact and adjust the design accordingly. So in terms of the approach here is take an existing toaster, and again, really now redoing what they will have done in their freshman year at a higher level to assess the life cycle impact, understanding the customer needs. So again, related to what they did in their sophomore year, figure out a toaster, a particular market that would make use of a toaster, and try to tune their design to those needs. And then in terms of the student outcomes, so they had to create a model, and they also had to look at the way of presenting this to potential investors in terms of raising support for this. And so they had to understand who their target audience would be, why people would want to pay for this, what sorts of groups would want to invest in this sort of toaster idea. And so in the upper right, you can see their sales pitch promotion. You could see in the lower right their their prototyping model, where it actually did have to toast. And then at the bottom is looking at the score. And one of the things that it was, I think, somewhat disappointing for the students, but also important to realize is, as you see, the two different scores are not that different from the original toaster to their design. And this was part of the challenge for them to realize that simply focusing on one effort in fact had potentially not paradoxical, but from a design perspective, improving one area led to reduced performance in other areas, and they can identify that they can't simply focus on one thing. And so it was a useful lesson for the students. The other one in terms of is that maybe the toaster isn't such a bad idea in terms of, from a toasting function, is already decent in terms of its sustainability score. So again, just looking at that more closely, this was a closer look. And so you can see in terms of the different parts, and again, what I want to highlight is there was a big push for the ecotoxicity, but notice that it suddenly changed in terms of human toxicity. So changing their materials where they were focused, sorry for my jumping mouse, around here at that 55 score, they're really trying to bring that down. And they did, but it came at the cost of other elements. And so for them, it was that trade-off study and recognizing you push one end and sometimes something comes out the other end that you didn't expect. Was a really good lesson for our students. So again here, what we have found at St. Louis University is we like using this as a complementary part of our design sequence. It's open-ended enough that our students can look at a wide range of design problems, but they can come up with an assessment, a way of assessing that from an environmental, from a sustainability standpoint. And again, for us, the idea that green development can mean lots of things to lots of people. So the idea of having a single score, a metric that they can work towards is extremely helpful for especially the engineering mindset in terms of optimizing the design. So having that approach and the broadness of it has been extremely helpful for our students. Again, for us as faculty, we enjoy having that tool that we can use, we can rely on, and allow our students to really run with their design.